I'm trying to put the cost of computation for AI into context. As you noted, there has kind of been this explosion of hype around artificial intelligence, about generative AI, and unlike crypto and Bitcoin and blockchain, there are some very practical uses for artificial intelligence, but
Oh
there's
yeah.
also some very practical and real world costs. Help me put this into context. What is the best way to think about it? Is it cost per search or cost per computation? What is the best way to think about the
Yeah.
energy use of artificial intelligence?
Well, ultimately, it depends on your use case. So you can use AI for a lot of things simply because AI in itself is an umbrella term. It captures just anything that is meant to make machines act more intelligently. And we got generative AI as a subset of general AI. But even generative AI is still an umbrella term. You can do language, you can do images, you can do whatever you want, music. um, what it ultimately, though, comes down to for most of these cases is that you're going to be training some kind of model to generate a certain output. And of course, what you're going to get out of that model is dependent on what you put into the model. And of course, there can be differences in, how do you model? What kind of approach do you leverage? But ultimately, the goal that you have when you're creating an AI model is to make solid predictions. Like if you have, let's make this very concrete. If we're talking about ChatGPT, we're talking about a language model, and that language model tries to predict the next word or sentence in a text, and that's the whole objective of ChatGPT. It's just constantly making predictions about what should be the next word or the next sentence in a text output. Of course, given a certain input. And how do you train that? Well, you just feed it a whole bunch of internet information that you can collect from, like, the internet is a very big source of information. You can feed it whatever. You can feed specific documents. You can feed whatever type of information you can come up with. And then what happens in the background is that you have a model, and in that model, during the training, the software will start updating the parameters of the model so that it gets better at predicting a certain output. Of course, based on what you put in. So it learns. I'm not sure if I'm really wording this correctly. I could use some ChatGPT here myself.
No, you framed the
Yeah.
product very well. Help me understand, though, that the training, my assumption is that the training of these large language models is a resource intensive process. Is that correct?
Yeah, and the the thing is, the more data you tend to put in, the better the output you get. The more parameters you have, the better the output you get. So right now there isn't really a plateau where putting in more data, putting in more or making use of more parameters um, stops increasing the quality of the output. So what we see today is that, especially the last couple of years, if you look at just the development of ChatGPT and the main engine that underlies ChatGPT, GPT-1, GPT-2, GPT-3, the amount of parameters that is being used by the model is just increasing exponentially. I think recently had ChatGPT 3, or sorry, GPT-3 is using 175 billion parameters, which is a mind-blowing number. But yeah, I mean, if we talk about Google's engine, recently they updated it, and now they're using 500 billion parameters, and these models just keep growing and growing.
So how energy intensive, how resource intensive is it to train one of these models, to train a GPT-3 or GPT-4?
Well, the good news is there's been some research, early research, mostly preprint articles that cover that question for various models. So we have some estimates for GPT-3 and we have some estimates for Bloom, which is a comparable language model. And I think they quantified it that I think GPT-3 took about 1,200 megawatt hours to train. Now, your average US household will consume about 10 megawatt hours on an annual basis. So you're talking about the annual energy consumption of about 120.
And is this an
You,
ongoing process? I know that OpenAI, for example, is training new models, or they're working on uh, training new models. Although they say
yeah,
GPT-5 will be long delayed, they're still perpetually training models, as is Google, as is
yeah,
Microsoft and Facebook. Every major tech company is training AI. So, what is the energy cost of this? Does it
yeah,
come
there,
close to, say, Bitcoin, where we had these
yeah.
stories about Bitcoin farms and loud processors? Put this into context for us.
Yeah, the difficult thing with AI and delivering these type of models is that the training phase is not necessarily something that happens continuously. Like if you train a model, you can deploy it and you're done. Um, the thing is, everyone wants to get or put out the best model. So what we see is that OpenAI is constantly training new models because they want to
Mm.
provide a better AI tool. And now, of course, all these other companies that are getting into AI are competing with OpenAI, and so they're also just making their models bigger, better, and it's arbitrary. Like you don't need to continuously train AI models. The training is something that you could do one time, but then of course, over time, the what you trained on may start to get outdated. So you do have to update it at some point, and then of course, especially if you're in this in this massive AI race where everyone's just competing for the best models, yeah, that's where all of the sudden you can get to a point where everyone is just putting in more data into these models, making the models bigger, adding more parameters to make the models generate better output. But it's nothing like cryptocurrency where you have a very a clear defined environment. There is a certain amount of money available. You put up more machines, you make more money. AI doesn't work like that at all. Training AI models doesn't work like that at all. Probably making a better AI model will help you getting a bigger market share, but like I said, it's more of an arbitrary thing. There is no ideal amount of data to put into an AI model. There's no ideal amount of parameters. For the moment, it looks like just making it bigger helps improving the quality of the output. We might reach a point where that stops happening, where the models just don't get better anymore.
What
Um,
about what about the cost per computation or per
yeah,
search?
you know,
So we know that a search on Google costs X, but a search on, or a chat instance of, or a computational instance of ChatGPT might cost Y. Which is more computationally heavy? And do the costs go down with scale like it does with search?
so now we get to the interesting part, because whereas training can be like a one-time thing, um, deploying the model and delivering the model is more of a continuous thing. So if you have a standard Google search today, yeah, I mean, Google has everything indexed, and hey, if you do a Google search, then it just puts out a very quick result. But then if you make everything like a Jet GPT engine, then you need to put every request through all those billions of parameters. that you have in the background for every single request that you make. So if you have ChatGPT and you have 175 billion parameters, every interaction you have with that interface needs to be processed with all of those parameters in the background. They all need to contribute to generating your answer, and it needs to happen quickly because you don't want to be waiting for half a day to get a response. So and the thing is, the developments right now are so AI is such a big hype that at the moment, to just be able to deliver everything faster, you need a lot more machines. You need a lot more machines in parallel to be able to deliver everything. And over time, of course, the machines may get better, and they may there may be more specialized AI chips that help you deliver these results, or a lot more results a lot faster. But the thing is, the development in technology is not as fast right now as the demand for AI is going up. So right now, today, yeah, okay, you increase the amount of parameters in your model, you're going to have to scale up the amount of machines you have available as well, if you still want to deliver results as fast as you would otherwise. And that can have a pretty big impact, at least on the short run. And this is where things get a little bit complex, because then we're talking about adoption curves, like how fast is everyone really going to be using AI? If it doesn't really catch on, yeah, then of course the development in machines may start outpacing the growth of these models and the energy demand as a result of those models. But that is a bit of a speculative domain. It can go multiple ways, and no one can really predict whether AI is really going to be adopted at the scale as big tech companies think it will get adopted. They're pushing it very hard, but we also see that a lot of people that interact with ChatGPT, at least for now, there's a lot of people that use it one time and they're like, okay, now I've seen it, yeah, it was fun, but I'm not going to use it again. So we have to see whether there's going to be a real behavioral change going forward. That's also a very big open-ended question, and we just don't know. I can't predict the future. No one can predict the future. But if demand for AI really goes up, I mean, we're talking about companies like Google that already have a reach of billions of users around the world. So they can make this technology accessible to a lot of people right now. And that's one thing that is important to realize. And if everyone actually wants to use it, well, I did do the numbers a little bit. If Google currently handles about 9 billion searches a day, if every one of those interactions was would have the energy or intensity of a ChatGPT interaction, then the amount of energy required per interaction would probably go up tenfold. So that is the difference between just delivering a Google search and the energy intensity of delivering a ChatGPT-like output today, where you have your result coming from those really big large language models. And
I'm sorry, go ahead.
Yeah, I wanted to add that for Google as a whole, I think some research is quantifying that over the past years, the energy that Google is spending on AI has been relatively stable. They quantified that about 15% of Google's total energy consumption was related to AI, and Google as a whole in 2021 consumed close to 20 terawatt hours of electrical energy. If you're talking about 15% of that, you're talking about 3 terawatt hours of electrical energy that Google is using for its AI part of the business. Now, if we compare that, for example, to digital currencies like Bitcoin, Bitcoin is responsible for consuming 140 terawatt hours of electrical energy per year. So that's still a lot more. But now, if you want to do, if you want to turn Google's business fully AI, so let's assume that a standard Google search just disappears and we're going to do everything with AI. In order to be able to do that today, just so let's also assume that everyone will want to do this within the next couple of weeks or months. It's not very realistic, but if that was the case, we could actually see that Google will probably require as much power as a country like Ireland to power the machines needed to deliver that. So if you want to do 9 billion ChatGPT like interactions per day rather than 9 billion Google searches per day, Google's total power demand may even double, also including the company's other activities. For example, cloud. That's not going to change. They're still going to provide cloud services. And then we are talking about, maybe substantial amounts of power, because we have just been talking about Google and Google consuming as much power as a country like Ireland just to do AI is pretty significant. Then you're talking about 25 terawatt hours of electrical energy consumption, and that's just Google. And now all the other big techs are also getting into this. So Amazon, Apple, Meta, and then of course we start seeing that things could escalate, especially if all these companies just continuously compete with each other and race to create the biggest, most powerful model out there. If you think back to cryptocurrencies, Bitcoin has been responsible for 0.5% of global electricity consumption, but the miners that are responsible for that energy consumption, they have been able to get to that level while they make just 10 billion a year from mining Bitcoin. And 10 billion is like a lot of money, but if you look at what big tech companies are earning, then you realize it's not a whole lot of money for them, because the 5 largest tech companies last year had a pre-tax profit of 300 billion. So if they only put the slightest amount of their resources to AI, then they could make the energy consumption related that could probably dwarf Bitcoin in no time. That's and it's hard to predict whether they will. Of course, they have other focus areas. They're not just AI companies. They have many areas that they have to compete on. But still, 300 billion in pre-tax profits. Yeah, they only need to put a limited fraction of that towards AI to have the same impact that Bitcoin miners are having today.
It sounds like this is a carbon bomb waiting to go off. Am I wrong?
It has the potential to be. It's sure that AI is energy intensive, but a lot is dependent on the adoption curve of AI. If the adoption curve is very slow, we have seen that historically machines also develop. So if the adoption curve isn't too fast, then maybe the development in the machines to deliver those results will also outpace the demand for AI, and this is where the predictions become really difficult. If everyone wants to do AI in the next couple of months, then we're going to have a big problem, because I don't even think that's possible, because players like NVIDIA, NVIDIA actually dominates the market for the chips that are used to deliver AI at the moment. I think they have a market share, or estimated market share, of 95%. They did predict a pretty significant increase in their revenue in the next couple of months. But in order to facilitate let's say, the energy growth of a mass AI adoption, they probably don't even have the production capacity to create all of those machines at the moment. So that's actually a little bit of good news if you take it from a climate perspective. Like, okay, the energy consumption can rapidly escalate, but at the same time, there are some constraints in manufacturing. That's one of them. Data center space is another one. Hey, you need to host those machines somewhere. You can't just put a machine in the wild. So there are some growth constraints, but yeah, how constrained is that growth when you have, like I said, 300 billion in pre-tax profit available? They have a lot of money at their disposal to clear some of those bottlenecks if they really want it. So ultimately, it really comes down to how big is the demand for AI gonna be? Is this like a hype? I mean, cryptocurrencies have been a hype for a couple of years, and now we see that everyone's moving to AI and no one is talking about cryptocurrencies anymore. Maybe AI will have the same fate, and then it won't be as bad as it could be. But yeah, if it's not just a hype, or if a substantial part of the population is actually going to be using AI on a regular basis in the very short term, then yeah, this could definitely drive up our total energy consumption globally.
Unlike Bitcoin or really any other emerging technology, AI might have the potential to help offset or even solve, air quotes, climate change. Is that potential a reality?
Well, there is a lot of hype around AI, and in the end, AI comes down to making predictions based on statistical models, and statistical models have been around for much longer than the term AI probably. And so far they haven't helped us solve climate change. That's we might get some good things from AI. I mean, some cool things, maybe some useful things. But a few years ago, everyone was saying blockchain is going to solve every problem, and then later on we realized, well, it's a bit more limited in the amount of actual use cases. And you probably don't need an AI for everything either. I mean, we probably managed to find information without AI before. We have seen AI have its own limitations, not just in terms of the energy required in the background, but also in the terms of output it delivers, because it's based on statistical models. There's always a certain error rate. I mean, this is common when you're working with statistics. You're working with confidence intervals, and you're always going to have some level of less useful output, or potentially even wrong output. So will this still, is this going to replace humans completely? Well, I think you still need humans to validate whatever your AI model is going to put out. It might change the way we work, but I'm always a bit careful in saying that this is going to be the next big revolution for everything, and going to solve every problem we have out there. That's probably a bit too much anticipation, especially when you consider that the thing that's underlying AI, AI is a hype term. It sounds very cool, very fancy, but in the end, it just boils down to statistics.
Alex, your work is a cold dose of reality. Where can we go to learn more?
Well, I would definitely recommend to just check out my research page. I have a ResearchGate account, Alex de Vries. You can find all of my past papers there. Also, my future papers will be there. One is coming on AI specifically in the very near future, hopefully, although in academics things don't go as fast as in AI. But yeah, I mean, that's probably a good starting point. And then, of course, my research is making many references to others that are also working on the topic. So you can work your way from there.